viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Arbit College, University of Delhi. So in this ongoing series of our operating system concepts, we have started with what actually its operating system is and how it is being defined and what is its kind of position in between position in the system, whether it is in the hardware, software. That all those concepts we have already covered, and today's agenda is views of operating system. So when we say that views of operating system, what actually we mean by it? So let us try to understand the concept. So views of operating system from its usability point of view. So we have seen that it acts like a government. It is a software. It acts like the manager of the services and so on and so forth. It also provides some interfaces. So basically there are kind of various, I can say, services, interconnections, interfaces, components which are being provided by operating system. So when we see operating system as an entity, what views we are going to have? So there can be three views which from the usage or vantage point of view. So one view which focuses on the services which it is going to provide. That means what kind of services an operating system provides. That is one view. Another view is it is an interface between the user and the hardware. So it is an interface for the users and the programmers, which is used in order to or which helps users or programmers in order to we can say use the system. So it is kind of an interface which helps users how they are going to be how they are going to utilize the system. That is one view of looking at operating system. The third one is about the components and the interconnection. What all components and what all interconnections are available inside the your operating system things. So we'll be covering in detail in today's lecture. We'll be covering in detail all the the first view, which is focusing on the services. So let's see, when we talk about the services that the operating system provides, what does it mean, which services we are talking about, and what is the meaning of those services. So when we talk about operating system services, we say that it is a kind of it is like a manager. So it provides some services to the programmer or to the users of the system or users of those programs. So basically these services are provided for the convenience of the user or for the convenience of the programmer. We can say what all services here it could be. So in order to understand that, let us see that the figure which is available on the screen, it is giving a view of operating system services. So if you can see, there is a light blue portion containing some gray as well between the two white layers. The uppermost white layer is about user and other system programs, and please remember your operating system is one of the system programs. So the uppermost layer is the user, and then we have a blue box which comprise of the whole operating system, its services and everything. And the last one, which is again white in color, gives you the layer of hardware. So if you can see, your operating system along with its all user interfaces, along with its all system calls, kernels, service modules, this operating system as an entity is switched between, or it is kept between user and hardware. Now why it is kept between user and hardware? Because whatever command is given by the user, that has to be executed by hardware, and the we can say the communicator here, or one who is going to provide the bridge between user and hardware, is the operating system. So user gives some command, operating system takes that, get them executed by hardware, and then replies whether in positively whether that command has been executed, or if there is an error, that error is also reported to the user. So we can consider one way user is communicating to the operating system, and operating system in turn is communicating to the hardware. Hardware gets the thing done, and then the return reply message, positive or negative, whatever it be, it is going to be provided to the user through operating system only. So operating system is the layer which is operating between the two, which is operating between the user and the hardware. Now drilling down inside the layer of the operating system, what we see. So basically here we see three portions. One is about user interfaces, another one is about system calls, and third one is about the services. So presently we are going to focus on the user interfaces as well as services. System calls we have already seen in our initial lectures. So when we talk about user interfaces, there are three. One is GUI, another one is batch, and third one is command line. We will be exploring them in a greater detailed length. Coming to the services provided by the operating system, these are program execution, input output operations, file system, then communication, then we have resource allocation, also accounting, then error detection plus protection and security. All these services are also provided by the provided by the operating system, and these services are provided either to the system or to the programmer. So basically these services are going to we can say make the work of programmer or the execution of programs by the programmer, it is being made easy by all these services. How? Let's try to focus on one by one, on all the services one by one. So first of all, let us consider the first layer, which is user interface. So we are aware that almost all operating systems have a user interface, which is in short is known as UI, and this interface can be of several forms or can be of several types. So one is CLI. CLI stands for command line interface. Another one is the batch interface, and third one is GUI, that is the graphical user interface. Now command line interface, if you have seen the interface of disk operating system DOS, that is a command line interface. That means each and every task which a user wants to execute or which a user wants to do is communicated with the help of a command, with the help of a written command. So for example, you need to copy one file from one particular location to another location. For that you have a command which is kind of move. If you want to make a particular folder, you have a command to make a particular folder. If you want to go into that particular folder, it cannot be done with the help of a mouse, then you need to put in a particular command. So for each and every task, for each and every work, for each and every action, user needs a particular command, and the interface through which the user is going to talk with the system, and that interface is provided by the operating system, that is in the form of command line. So nowadays if you want to have a feel of command line, you can go to the command prompt from your search menu, and then you can have a blank screen saying C drive or something like that. That means your current directory. So all those tasks which you want to execute are to be done through the help of writing the commands over there. I remember programming in DOS was completely or working in disk operating system, which is one of the earlier operating system. So disk operating system DOS was basically a CLI, command line interface, and each and every task needs a separate command, be it writing in a file, or be it kind of moving a file, be it creating a directory, whatever. All those things needs separate commands. But nowadays if you see your Windows operating system, or Ubuntu, or any other for that matter, what do you see? We have a different way of interacting with the system. We have a different kind of interface, and that interface is nothing but graphical user interface. So that graphical user interface, which is GUI, works with the help of, let's say, let's take the example of Windows. You have a desktop screen. So, and on that desktop screen you have small icons, you have some folders. Now let's say, for example, you need to make a folder. What will you need to do? You just need to right click your mouse and then go to new and then folder, give the name of the folder, and simply you are done. For example, you need to move one file from one particular folder to another. What you need to do, you can just drag and drop that particular file from one location to another. Or what I'm trying to say, basically, that can be done with the help of the mouse. You need not to write any, you need not to have any written command for that. Earlier in command line interface, this all was done with the help of commands, and the irony was that user needs to remember all those commands. Then only, if there is a syntax error in the command, then that command cannot be processed. So each and everything user need to remember and then perform the task. But GUI has made the life of user or the life of programmer very, very simpler as compared to what it was in the CLI days. So now everything is available in the format, in a graphical format, and GUI is very, very easy to work. So that's basically, the interface was changed from CLI to GUI. Now the next type which is available here under the user interfaces is batch interface. So batch interface we will be covering in detail in a short while, but let's try to explore a little about this. So batch interface is something in which a user does not directly interact with the computer system. Instead, it is going to submit the task, or it is going to submit the job to the operator, and then the operator is going to make the batch of similar jobs. When I am talking about similar jobs, that means similar in terms of requirement. So that batch is going to be made, and all those jobs which are consolidated or which are kept together inside the batch, that particular batch is going to be executed by your computer system. So that is what you called a batch interface. When in the upcoming lectures we will be going through batch operating system, we will be covering more details about the batch interface also. So till this point, what we have covered, we have seen views of operating system. So views of operating system is all about how one can see, how one can utilize the operating system as an entity. One can see operating system as an interface between the user and the hardware. One can see operating system as a mode of communication and interaction, or one can see operating system as a consolidated, as a big module of services in which there are various services having each sub module. So then we have started exploring the user interface, and we have seen what kind of interfaces are being provided. So we can have your command line interface, we can have graphical user interface, or we can have batch interfaces. Now moving forward, we see what all others. So this interface is one of the services, we can say, yes, it is one of the services which is being provided by the operating system to the user or to the programmer. Now coming to the next services, because the first view which we are considering is all about the is all about the views. So the first views of operating system, and we are considering first view, that is service allocator or service operating system as a service provider. So the first view, the first service was an interface. Three types of interfaces we have seen. Now coming to the second service, that is program execution. So now program execution means that the system, it is required by a system to load a program into the memory in order to run that program. That we have already seen that the program which we need to run, that program has to be there inside the memory, and then when it is running it must produce an end, either normally or we can say positively when it is kind to be done with the execution or done with the task, or maybe abnormally it's going to indicate an error, the execution is not successful, or it is going in an infinite loop or whatever, but by some or the other way the program must be able to end its execution, whether it is normally or abnormally. That is point of that is with the help of indications of some error. But that program execution, the service of program execution, that is loading of a program in order to run that inside, loading of the program inside the memory in order to run that, is a service which is given to the system or which is given to the user by operating system. So, operating system provides the service of program execution. Coming to the next service, which is input output operations. Now, let us see what happens. Let us say for example, we are going to have only a simple program which is sum of two numbers. So, that program has started execution, and then now it is a CPU was allocated to it, and now it is asking for two numbers which are to be summed up. So, basically what point I am going to highlight, what point I want to highlight here is a running program may require an input output. Input output here could be a file device. A program needs to read something from the file or write something onto the file, or maybe an input output device, as I have given the example in which a keyboard interruption is required, or an interruption is required in which the keyboard is going to give some data, is going to give some input to the program. So, there is a running program which needs some input output activity, or maybe for some specific devices some special functions may be desired, such as we are going to record a CD, or we are going to clear a display screen or something of that sort. So, it is inevitable that these input output devices are kind of needed to be controlled, and users are not supposed to control these input output devices directly, just for the issues of efficiency and for the protection. So, operating system must provide a means to do some input output operation, and operating system is as one of its sub modules is there in order to provide input output services to the programs, because users are not allowed to control input output devices directly for the protection and efficiency reasons. So, input output operations are being provided by operating system, means whenever a running program needs an interruption or needs, let us say, two numbers from the keyboard, it is the operating system who is going to switch that particular program from CPU to input output devices. That switch has to be done, or that switch has to be given, switch has to be facilitated by operating system. The third service after user interface and input output operations is file system manipulation. So, one example we have seen, that is taking two numbers from the input devices, and what happens if the sum of these two numbers is needed to be written into a file, or another scenario could be these two numbers are to be read from a file. So, basically the bottom line here is programs need to read and write files, or maybe directories depending upon their application. They also need to maybe create and delete files, directories. They need to search for a given file, they need to list some file information. So, basically programs are going to deal with files heavily. and again it is up to the operating system to include or to manage all the permissions, whether to allow the access, whether to deny the access, whether to how to manage directories based on their file ownership, and even if access is kind of granted, which or access is allowed, till what all access is, whether it is read, write or executable, what all accesses or what all permissions are allowed for a particular file to a particular user, that whole scenario is being managed by your operating system. Then coming to the next, we can say what next service is, which is about communications. Now communications means, for example, we have common a normal operating system or maybe a distributed operating system. There will be some circumstances in which the one running process or one process needs to exchange information with the another process. Now this another process could be on the same computer or between the processes that are executing on the different computers tied together by a network. So the two communicating processes can be on a single system or can be on the different system, and these two different systems are connected with the help of a computer network. So now how is this communication being done, or how is this communication being executed? This communication is going to be implemented via a piece of memory which is known as a shared memory, and all the processes which we needs communication with each other, which want communicating with each other, are going to use that piece of shared memory, and this whole shared memory and this whole communication is controlled by operating system. So we have seen user interfaces, we have seen program execution, then we have seen file manipulations, input output operations, and also some communications. Moving forward, we have some other services which are provided by operating system. That is, one of them is error detection. So operating system needs to detect the error and correct the error if it is kind of possible for the operating system. So what I am trying to say here is, for example, a program is running and there is an error of invalid input, then that invalid input has to be communicated to the user has to be, or the programmer has to be informed that the input which is being provided is not appropriate, is not up to the mark, and then that that error will be corrected by the user. So there can be various types of error. These errors can occur in either in CPU or memory or hardware. Even our power failure or memory overflow, all these are errors, or these errors can occur in input output devices. For example, unestablished connection to a network, or a connection failure we can say, or there is no paper in the printer, so that's an kind of an output error, or it could be one parity error on the disk which is related to some you can say software. So there could be errors inside the input output devices. There could be errors in the CPU and the memory hardware. Apart from that, there could be error in the user program, such as I have given you the example of invalid input, or maybe an attempt to access an illegal memory location, or great use of a high use of CPU time, or could be an arithmetic overflow, or anything inside the user program. So either the CPU, memory or hardware, or input output devices, or the user program, they may contain error. So now there will be various types of errors, and for each type of error the operating system needs to take appropriate action in order to ensure correct and consistent computing. Operating system has to take the kind of relevant actions which are relevant according to the type of error which is occurred, because the system has to be kind of, we can say the processing has to go on and system must be kind of in working state. But sometimes operating system has no choice but to halt the whole system, but that's, I can say, is the last option. At the other times it might terminate an error causing process or return an kind of an appropriate message with the help of an error code to process, for the process to detect and possibly correct. So for example, I told you invalid input. So this error code, invalid input, or maybe an arithmetic overflow or something of that sort are having their special codes. These codes are kind of communicated, and then corresponding messages are given to the user because it's easier for a user to understand the messages. So at which point of time, in case of an error, what kind of condition is going to be what kind of action is to be taken, that is to be decided by operating system. Another one is resource allocation. So resource allocation we have already kind of discussed a lot, in the sense that we have seen there are many resources inside a system. It could be CPU cycles, main memory, files, system, storages, your disk, and so on and so forth. So which resource, even your input output devices are the resources. So which resource is to be given to which job for how much time and in which mode, when these are to be released, that all thing is managed by operating system. It is not only managed by operating system, but under the section of accounting, a whole track of all the users, all the jobs basically, that what all resources they are using for how much time are to be kind of maintained. That whole accounting is to be maintained, and this accounting will be useful when the users are to be built, or kind of a usage statistics for the from the point of view of research, in order to improve computing services is required. So that accounting is also done by the operating system. Then we have last is protection and security. So protection and security comes under, let's say we have an information which is stored in a multi-user system or maybe in a networked system. So obviously the owner of the information wants to control the use of that information. So the protection involves ensuring that all access to the system resources is controlled by the appropriate entities. Security of the system from outsiders is also important. For example, when you try to log in into a system, or when you try to start a system, it needs a password which is through which a user is authenticated. So that's also kind of a security measurement. So all security and protection mechanisms are to be managed by operating system. So in this lecture we have seen what all services will be covered, what all services are provided to the system or to the users of the system by operating system, and we have seen each and every service in brief detail, and here is a list of references which is being used for the preparation of the lecture. Hope you had a fruitful learning. Thank you.